Oh, welcome to a quick help presentation on the incline plane problem that went along with our friction on an inclined plane lab. What I want to do here is talk you through here this type of a problem. We have not done a purely algebraic solution, I don't think yet, for the AP questions, the practice things that we've done. But it is a common feature of the AP exam that they ask you to fully solve problems algebraically. And so I'm just going to show you, in case you need a little help, make you feel more comfortable with this type of a problem. Let's start though with doing your free body diagram for block number 1 for what's described here. I'll pause the presentation and let you go ahead and do that, and I'll resume with my answer for the free body diagram. All right, I show 4 forces acting on the block number 1 as shown here. Now, what I want to point out here is for doing these problems where they ask you for an algebraic solution, let's go ahead and do this part B, where they ask you for the coefficient of kinetic friction for block 1. But they ask for it in these terms right here. And so the way we'll do that type of problem, maybe go ahead and try that yourself. Go ahead and write out a statement to solve for the mu, or coefficient of kinetic friction for block 1. Now in this case right here, we can start with the basic formula for friction, which is the friction force will equal mu times the normal force. Put it into the format that they ask for, which is for mu, of course, and that's friction over the normal force. And then we might ask ourselves if we're done. In other words, would this be a suitable answer for the AP exam? And the answer, of course, is no, because the normal force is not one of these symbols that they've asked for right here. So for the trick for these algebraic solutions is to have to make sure that you put them in the format that they're asking for in the problem. Now that's actually not that hard to do. If you come back to the free body diagram, I'll help you a little bit here. You'll notice that the normal force, which is the force that we want to put into our equation, is of course balanced in this direction right here, because the block is not accelerating away from the plane or into the plane. So there must be some balancing force there. Of course, that force that's balancing with the normal force we have dealt with before, and we've done it by dropping from the normal force a reference line, continuing a reference line in this direction and calling that our y direction. And then noticing that the weight vector has a component that acts along that line. Looks a little something like this. And we can draw this kind of a tipped right triangle like this, where our angle here turns out to be the same as the angle of incline, or theta. So with this information here, it should be pretty clear that this normal force is balanced with this component of the weight. That component of the weight can be solved for in terms of the mass of the object, g, and the angle of incline. And I'll let you go ahead and do that yourself. But you'll substitute it in here, and now you'll have the equation in the format that they ask. This is going to be the procedure that you use now for the other problems that are on the sheet. So let's just go ahead and take a look at them. Now on the next page we have this problem right here. Now I'm not going to get into the individual solutions here, but I am going to give you some guidance. We're going to use the same format that we did before of using algebra for each of these solutions. And in this case right here, I'll just tell you, when they ask you to determine the value of the suspended mass m that allows block 1 and 2 to move with the constant speed down the plane, I'm just telling you that you're going to have to do 2 free body diagrams. So you're going to need to do a free body diagram for the suspended mass, the hanging mass, and then you'll do a free body diagram for blocks 1 and 2. Now I suggest, as a simplification, that you treat block 1 and 2 as a single object. In other words, you combine their masses and you combine the other effects associated with them being on the block, and it just simplifies your problem. Now what I'm going to say is this, is when we're done with this, let me go back to I'm going to go back to the previous page here so we can look at this picture right here. When we come back, when we finally get done with those 2 free body diagrams, you are going to notice that this system over here and this system over here, we can write free body diagram and therefore Newton's law equations for each of those systems. But each of those systems share a quantity. And the quantity that they share, I'm just going to tell you right now, is the tension in this string. Remember that tension goes throughout an entire string. So the tension on one side of the pulley has to be the same as the tension on the other side of the pulley. So if you have two equations, but you have one term in each equation that's the same, you should be able to use algebra to come up with a combined solution. And that's what you're going to do here. Just to give you a tip, the final solution does look a little bit complicated. So if it looks complicated, it doesn't mean you've done something wrong. Okay? Now in this last thing, we're back to looking at just block 1 again. You're going to do a new free body diagram for block 1, but notice that now the string is cut, right? So therefore you're going to have, instead of 4 forces on your free body diagram for block 1, you're going to have 3 forces. Forces are not going to be balanced anymore because you've lost one of them, and therefore the block will not be balanced, and therefore you're going to have some kind of an acceleration, and you should be able to write an algebraic solution for A for block number 1 using your free body diagram and your solution. Hopefully that helps you out. I'll go ahead and grade these when they come in on Wednesday and provide you with a full solution. But hopefully with this, these tips, you should be able to find some success in working these algebraic AP problems. Thanks for joining me.